Computer science is changing. Most universities haven't caught up. Right now, students are still being taught how to code line by line, memorize syntax, build small projects, pass exams. But here's the uncomfortable truth. AI can now generate code in seconds. And what happens when the skill universities focus on the most writing code becomes partially automated? Does computer science become irrelevant? Or do we need to completely rethink what we teach? Because something strange is happening. Junior developers are using AI tools daily. They generate boilerplate code, they debug faster, scaffold entire projects with a prompt. Some people call this progress. Others call it vibe coding. You describe what you want. The AI writes it. You adjust. You ship. But here's the danger. Students graduate knowing only how to write code manually and not how systems actually work. They risk becoming dependent on tools they don't understand. And that's where things get serious. Because AI doesn't replace computer science. It replaces shallow understanding. Let's break this down. In the tech world, there are multiple roles. Junior coders, mid-level developers, senior engineers, system architects, security analysts, infrastructure engineers. Not all of them are equally vulnerable to AI. If your job mainly involves writing repetitive boilerplate code, yes, AI tools can handle large parts of that. If your job involves designing distributed systems, understanding performance trade-offs, securing infrastructure, or architecting complex applications, AI becomes a tool, not a replacement. That distinction matters. The problem is that many computer science programs still emphasize syntax over systems. Students learn programming languages. They build small apps. They pass coding challenges. But do they deeply understand how operating systems work, how networking functions at the protocol level, how compilers transform code, how memory management impacts performance, how distributed systems fail under load? These foundational topics are harder. They're not flashy. But they're exactly the areas where human judgment remains critical. AI can generate code, but can it take full responsibility for designing fault-tolerant architecture in a financial system? Can it be legally accountable for security vulnerabilities? Can it evaluate business trade-offs in a high-stakes environment? Not yet, and probably not soon. What's at risk isn't computer science. It's entry-level coding as a standalone skill. If universities continue teaching students as if manual code typing is the primary value, they risk preparing them for a market that no longer exists. So that's the real problem, because AI isn't killing computer science. It's exposing weak education models. Now, here's where it gets interesting. Students who learn how to use AI intelligently while deeply understanding systems will have an advantage. They won't compete against AI, they'll amplify themselves with it. Instead of spending hours writing repetitive code, they'll focus on design decisions, security models, scalability, performance optimization. AI handles syntax, humans handle strategy. But if students only learn surface-level coding, they become prompt operators. Prompt operators are replaceable. So the real question isn't, will AI kill computer science? The real question is, will computer science education evolve fast enough? Because if it doesn't, we're going to see a generation of graduates who know how to ask AI for code, but don't know how to evaluate whether that code is safe, scalable, or even correct. And that's dangerous. But this conversation gets deeper, because not every tech role is equally exposed. And understanding which roles survive and which shrink is the key to future-proofing your career. That's what we're diving into next. Let's break down the tech roles one by one, because AI doesn't hit everyone the same way. First, junior developers. This is where the pressure is strongest. Junior roles often involve writing boilerplate code, fixing small bugs, implementing predefined features, following clear instructions. These tasks are structured, predictable, pattern-based. That's exactly where AI performs well. Given AI enough context, and it can generate login systems, CRUD apps, API endpoints, and basic UI components extremely fast. If a company can use one experienced engineer plus AI instead of 3 junior coders, that changes hiring patterns. This doesn't mean junior roles disappear, but it does mean expectations shift. Companies will expect juniors to understand how to validate AI-generated code, not just write code manually. Now let's move up. Mid-level developers? These roles require more than syntax knowledge. They involve understanding project structure, debugging complex interactions, and making design decisions within existing systems. AI can assist here, but it struggles with context across large code bases. It doesn't always understand long-term architectural trade-offs. Mid-level engineers who deeply understand systems become even more valuable, especially if they can use AI tools efficiently. Then there are senior engineers and architects. These roles focus on system design, scalability, planning security models, infrastructure decisions, technical leadership. AI can suggest patterns, but designing a distributed system that handles millions of users, that requires experience. It requires understanding failure modes, performance bottlenecks, regulatory constraints, business priorities. AI doesn't hold accountability, humans do. Security roles are another interesting case. AI can help detect patterns or scan for vulnerabilities, but cybersecurity requires adversarial thinking. It requires anticipating creative attacks. It requires understanding incentives. Attackers also use AI, which means defensive security roles become even more strategic. Now here's the important shift. AI compresses the lower layers. It increases productivity at the bottom, but it increases responsibility at the top. That means education must evolve accordingly. Instead of teaching students to memorize syntax, universities should emphasize how operating systems manage processes, how networking protocols interact, how databases scale, how concurrency causes race conditions, how memory leaks impact performance, how systems fail under stress. These concepts don't become obsolete with AI. They become more important, because if AI writes the code, someone must verify that it's correct. Someone must understand the underlying principles. Otherwise, we risk building massive systems on foundations no one fully understands. That's not innovation, it's fragility. Another overlooked area is communication. As AI generates more technical output, engineers who can explain decisions, document systems, and coordinate teams become more valuable. The role shifts from code producer to technical decision maker, and that's a higher level skill. Now let's address vibe coding. Vibe coding is when you describe a feature, the AI generates it, and you iterate until it feels right. For prototypes, this is incredible. For learning basic concepts, it's powerful. But for production systems, blind trust is risky. If students graduate without understanding how to debug at a deep level, they may struggle when AI-generated systems break in unexpected ways. And they will break. Software always does. So the real danger isn't AI replacing computer science. The real danger is reducing computer science to prompt engineering. Because prompt engineering without foundational knowledge is shallow. And shallow knowledge is fragile in a high-stakes industry. But here's the hopeful part. Students who adapt, who combine deep system knowledge with AI fluency, will be unstoppable. And that's what we need to talk about next. How do you prepare for that future? So how do we fix this? If AI is reshaping coding, then computer science education needs to evolve fast. But evolve into what? First, we need to stop treating coding as the end goal. Coding is a tool. It always has been. The real goal of computer science is understanding systems, how computers process instructions, how data moves across networks, how operating systems schedule tasks, how databases maintain consistency, how distributed systems handle failure. These concepts don't disappear because AI writes code faster. If anything, they become more critical. Because when AI generates thousands of lines instantly, someone needs to know whether those lines make sense. That someone should be you. Second, education must focus on problem modeling. AI is great at implementation when the problem is clearly defined. But defining the problem correctly? That's human work. Students should practice breaking complex challenges into structured models. They should learn how to think in terms of constraints, trade-offs, performance limits, and security risks. That's what separates a prompt operator from an engineer. Third, universities should teach AI as a co-pilot, not a cheat tool, instead of banning AI in coding assignments. Imagine teaching students how to evaluate AI-generated solutions, spot logical flaws, refactor poor structure, measure performance impacts, test for edge cases that builds judgment. Because the future engineer isn't someone who types every character manually. It's someone who knows what good systems look like. And here's something important. AI doesn't eliminate competition. It raises the bar. If everyone can generate basic apps, then basic apps are no longer impressive. Depth becomes the differentiator. Understanding becomes the advantage. The same thing happened when calculators became common. Math education didn't disappear. It shifted toward understanding concepts instead of manual computation. The same thing happened when compilers automated machine code. Engineers didn't vanish, they moved up the abstraction ladder. AI is just the next abstraction layer. Now let's talk directly to students. If you're learning computer science right now, don't panic. But don't be passive either. Learn how to use AI tools efficiently, but also learn what's happening underneath. Understand memory allocation. Understand concurrency. Understand networking fundamentals. Understand how databases handle transactions. These are timeless skills. If you combine deep understanding with AI productivity, you become extremely powerful. If you rely only on AI, you become dependent. Dependency is dangerous in fast-moving industries. Now let's talk about companies. Organizations need to rethink hiring too. Instead of asking candidates to solve algorithm puzzles under pressure, maybe we should ask, can you design a resilient system? Can you analyze trade-offs? Can you review AI-generated code critically? Can you explain architectural decisions clearly? The job market will reward people who think, not just people who type. So will vibe coding kill computer science? No, but it might kill shallow coding education, and maybe that's a good thing. Because computer science was never meant to be about memorizing syntax. It was meant to be about understanding computation. AI just forces us to confront that truth sooner than we expected. The future isn't human versus AI. It's human judgment amplified by AI tools. And if education adapts, we'll produce better engineers than ever. If it doesn't, we'll produce graduates who can generate code but don't truly understand what they've built. And that's not progress. That's risk. The real challenge isn't AI. It's whether we're willing to evolve with it.